Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Welcome. You have found the Digital Enterprise Society podcast. Welcome back if you're a regular listener, or welcome to the show if this is the first time you have come across the Digital Enterprise Society podcast. The Digital Enterprise Society podcast, it is designed to be a resource for those who work in and around PLM. The Digital Enterprise Society, it is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, go visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, how are you today?
I'm good, Thom. I am anxiously awaiting for spring. I told you a month ago spring had occurred, and we had a regression.
Spring occurred, and you got snow in Michigan. Yes, I saw that. So.
Well, and Ohio and Indiana. There were a lot of places that got snow.
It's going to be 90 degrees in Austin, Texas today. We skipped spring. We went straight from like our winter apocalypse right into early summer. So that's
our forecast has 80 degrees in 4 days. So maybe we'll get there with you.
Awesome. Well, hopefully the Midwest keeps really good weather. For Mother's Day, I'm visiting Chicago because my daughter lives there. So I'm banking on really great May weather in the Midwest. So.
Yeah, it's just that all the flowers that were blooming are dead. So,
oh, well, there you go. Well, every single week, Craig and I try to bring to this podcast really interesting interviews and other ideas that are going to help all the listeners enhance and grow their careers. And today, we welcome back a repeat guest. In fact, because he is the current president of the Digital Enterprise Society, he might be our most featured guest that we've ever had on the show. So we welcome back Adam Specht. Now, he is the IT director of product development at Tenneco, and what he does is he manages CAD/CAM, CAE, and PLM tools for about half of the company. And he's a really good guy, and he's got some really good ideas, and today is going to be an awesome episode. So fasten your seatbelt, because here we go. Hey, Adam, welcome back to the show.
Thanks, Thom. Thanks for having me back.
Oh, always glad to have you. So really quick for people who aren't familiar with you, but if they're regular listeners, I think this might be your fourth visit to our podcast. Please give us a little background about yourself.
Right. So my background is primarily in mechanical engineering, actually. So I started out as a mechanical engineer early in my career. Spent quite a bit of time working on tools that support mechanical engineering and product development as a whole. And now, rather than just using the tools, I actually help identify how the business should use them, and then help establish the processes and really help establish the tools from an IT perspective. So I work really closely with all the product development groups around the world in our company. That's pretty much it.
So, hi, Adam. Welcome back. Okay, how does a mechanical engineer get in charge of IT? I'm just curious.
So I've always had kind of an affinity for technology and computers, and it was interesting because coming up, I got to get into college right as real internet connections started to happen, right as 3D CAD became ubiquitous in industry. So I started out in college learning on a drafting board, but then when I got my internship, the very next summer, I was running Unigraphics, and really got to understand the details of how it works, why it works, the way it does. And then as I got into my real actual professional career, I got dragged into a lot of business process discussions and into a lot of decisions about what the tools actually need to be and how they need to function. So going through those implementations and whatnot, back when it was Federal Mogul, they were actually looking for someone to help start up a kind of engineering IT practice to help bridge the gap between engineering and IT. And the value that I've brought to it that I think is kind of unique to people that have my job at other companies as well is that I can speak engineer, I can also speak IT, because they are not necessarily always the same language. Right?
Well, no, that's exactly right. And that's why it's important that the domain expert, meaning the expertise of mechanical engineering, have leadership roles in PLM. It's not just about servers and buying software. And that, at least the classical IT professional, that's what they do. They assume that if they install the tool, somebody else will figure out how to mold their process. It gets to this interesting point about process then tools, or tools then process. But
right.
But that, you and I have debated this a lot over the years as we've seen each other, and now we're all virtual. But anyways, you had an interesting topic, and this is what spurred us to want to have a chat with you about this in the podcast, about master data and digital thread strategies. Which comes first?
Right.
So before we get into the debate, we need to define for our audience what these are. So can you first define for us what you mean by master data?
Well, I think that it's not always the same definition for every company. But fundamentally, if you think of master data, it's that critical set of information about whatever the widget is that you are making or designing or doing, right? Whatever your product is, that critical piece of information that always sticks with it, right? So if I think of a nut that you fasten to a bolt, right? A nut is going to be called a nut, right? That's critical. Maybe the part number that you assign to it is going to be critical, and it's going to stick with that nut forever. But beyond that, you can look at all the other pieces of data that you might associate with a nut. For example, maybe the thread type, the plating, all those different things. Those may be other attributes, but aren't necessarily critical for every part of the process that it might flow through, right? So if you're mapping out the way your company operates start to finish, the life cycle of that product, whatever it is, whether it's a physical thing you're making or a design that you're outputting, whether it's a virtual, real, tangible, whatever, that critical piece of information that always sticks with it is how I define master data, because it is then used to propagate itself and tie itself to other things downstream through the process.
Well, I like what you just said. What criticalness is maybe beyond the current step, right? So it's critical if it's used by more people downstream. So in my experience at doing your kind of job at General Motors, we had long debates about what made a piece of data a piece of master data. And I really think one criteria could be it lives beyond the current work, right? So like plating, you use that example. Well, in the corrosiveness of a parts in the car business, right, we get pretty good at specifying plating characteristics. So to suppliers, we would say, well, you got to meet these requirements for plating. That might turn something that was an attribute into a piece of master data just because it's a requirement now coming from a customer, right? So it's never cut and dry what's master data, but you need to have the discussion and decide as a company what's just an artifact and what's the key piece of data.
Exactly. And really, depending on the size of the company and the complexity of it, it's really going to change. So if I look back at small to mid-sized companies that I've worked for or worked with in the past that maybe have a single ERP tool, maybe a single PLM tool, and it becomes much simpler, right? Because you're not worried about having to have so many critical pieces of data that you're going to then tie, that you're going to then leverage in downstream systems, right? Whereas when you get into a larger company, like you mentioned, General Motors, Tenneco, we have multiple ERP tools around the world. We have multiple PLM tools that we use, and you need to very, very carefully identify what that master data is so that you can then use it to link things together. So
how do you deal with the inevitable conflicts where people use a word but mean really different things? How do you govern out of that mess?
So it's a challenge. It really is. But that's where you come up with a dictionary, in all honesty. You need to establish your naming conventions for a part, right? Is it called a fastener? Is it called a screw? Is it called a bolt? Right? What is the difference between a screw and a bolt? That's a debate that I've had with mechanical engineers for years. And, it doesn't really matter so long as everyone has a clear definition throughout the organization.
Right. So the other term you used in this introduction is digital thread. So what do you mean when you say digital thread?
Well, I talk about it this way, right? A lot of people think of digital in terms of digital transformation as taking the old paper and putting it into a computer, right? And there's more to the concept holistically than just taking the way that we used to do it and putting it in a computer. When we talk about digital thread, you're really talking about the process that you do, that you use to manage your product development, your product lifecycle, start to finish. And the digital thread is really the linkages and the connectivity between all of those different steps in the process. There's a slide that I've developed that I've used in several presentations that really talks about, if you can picture in your mind a factory. If you just take all the tools and all the machines and put them into a factory, but don't connect them to anything, right? They're just standalone things. Imagine that factory without any wiring, without any electrical connections. That's what we're really talking about, is a company that doesn't have the digital thread. The digital thread, from a visual perspective, is really your electrical connections and all of those things that hook all of your machinery to a common, electrical hookup. The equivalent in the digital thread is the common process by which you link everything together into one common overarching how we do what we do. Okay.
So your position then, or your proposition, which comes first? Which comes first and why?
Well, again, I would say it somewhat depends on the size of the company.
Okay.
Philosophically, I would argue that the digital thread and your definition of your process is what really needs to come first, because then it should be clear to you what data is consumed at what steps of your process and who and when that data is generated. Now, master data, in my mind, is the stuff that is typically in your process, that which is created right at the very start. Right? So as soon as I decide that my screw is a screw, it's always going to be called a screw. Thou shalt not change the fact that it is called a screw. And that's a piece of master data. Throughout its life cycle, you might say that a screw is going to have different plating. You might change that, but fundamentally, the name of screw is not going to change. When we talk about interchangeability, those things that don't really change throughout its life, that's your master data.
So a bit of thread first, then data. Yep. But then once the data is established, it remains the master. So one of the conundrums I've seen is, well, thread sometimes is maybe a little bit too simple. And what I mean by that is this notion of, I've heard people use the phrase digital cloth. And what they mean by that is, well, this common part, I like this idea of talking about a fastener or a screw, it's used in multiple products. And so the context of how it's used changes, right? Is it bolting together, parts of a pump, or is it bolting together parts of a transmission or whatever? Well, the fastener doesn't care. It has to carry a certain load, right? The fact that it's a reused fastener just means the company that's buying it is smart about buying fewer parts, right? Because they can buy them in higher volume. So does your digital thread get broken or complicated when you got massive reuse, like reuse of fasteners?
No,
or is that where now master data is driving and the threads have to follow the master data?
Well, I would say that the threads follow the master data, but they work together. I wouldn't say they work in series or in parallel. They work as one because your master data flows through your digital thread. So one of the things that I have done in the past, and the people that work for me have kind of gotten used to doing this, is I love cross-functional swim lane diagrams of processes. This is one of my favorite things in life to do, to help understand how something is done, who does it at what step in the process, and you can then very clearly understand, what's done in parallel, sequence, all these different things. The piece of it that I've added in recent years, and this is actually a little bit of an outgrowth from some discussions I've had with some other companies, is think of a cross-functional swim lane diagram, right? You identify the different functions, you identify the steps in that, but then add in the layer on top of it, what is the data that you're consuming at that step? So what data do you need to do that specific task? And then from there, if you identify that for each task, you then identify the data that the people ahead of that task need to be able to generate, right? Now, if there is data at the start that flows through that whole digital thread, it's probably master data. If there's something that just two people look at to be able to decide, should I use screw A versus screw B in my design, because one is plated with hexavalent chromate and I can't use that because of certain rules, or one is black and I know that I need to have a visual look. That's good data to be able to see. That's that's classification of parts. That's your McMaster car catalog to understand the form, fit, and function, but it's not necessarily the critical master data. So that cross-functional flow diagram and being able to map the data as it is consumed and generated, it not only identifies your master data, but I think that it simplifies things a little bit as well. And that speaks to things like classification, because when you talk about stepping into the classification piece, right? We're having right now actually a discussion about what attributes do we need to apply to a certain set of our products. And if you ask a group of engineers, what attributes do you think we need to have to classify screws, right? You're going to have the thread, the length, the diameter of the head, the type of head, the plating, the color, and they're going to come up with this massive list of stuff that they think you need to do. They're going to open up the McMaster car catalog and they're going to say, I need all of this. Do you really?
Right. And they're going to flatten it and they're going to make it available to everybody. And it will be overwhelming.
Exactly. And then maintaining it is darn near impossible. But if you use the technique that I just talked about by identifying who consumes what data as that part is used through its life cycle, you're able to limit that data set down to what's really critical for the process. You're able to identify what really should go into a classification, but then you're also able to identify, all right, this piece of data that flows through the digital thread is really what's critical. That's my master data. So some of it's contextual in terms of how the part's used, but some of it really is critical for it, right?
So we debate, all of us in engineering, context, right? And there are different kinds of context. There's where are we in the program context, whether the part's reused context, even our experience with the part. We know this part will work because we've been using it for a long time and we trust the supplier. These contexts, maybe that's a better word than the kind of crazy word I used earlier about cloth, right? Because it's the context that describes how you use parts and reuse them. But then it's also a context of where you are in a program, whether you're early in engine development or late in engine development, right? And so I think context, the way you described swim lanes, some people would call these, organizational process models, the process of developing a product. They're really useful in determining master data. That's what you said, and I agree. I just hope the audience, if you missed what Adam and I just said, hit the rewind button about 5 minutes and play it over again. It's really interesting that the process can help you decide what really matters in your master data, which probably will drive back to then how you really make more money, right? What your profit margins can increase because you really know what to manage. You don't manage all the attributes that you were pointing out. You manage the key 2 or 3, or maybe it's 4, but it's not dozens. It's back to a couple. So
exactly
interesting. So now put this in the context of an engineer who's building a part and wants to use that fastener. How do they benefit from digital threads and master data? I mean, how does it help them do their job?
Well, one of the critical things as you're an engineer, you're going through design and you start to identify key requirements of either something functionally, right, or visually, right? You work with an industrial designer that says, well, I need it to look like a certain way. But then as you're starting to find parts, if you have the right data describing it, you'll start to understand, well, can I use this part over again? So it facilitates reuse. It facilitates less duplicate parts. So from an engineering perspective, it makes your job easier. So if you invest the effort up front to put the right data in place that describes whatever that part is, and you understand what that data means, then it makes your job more efficient and easier to do. And it even gets back to, is a part something that is purchased or manufactured, or what plants are it available in? All this information then helps you understand, can I use this in a design based off of where it's going to be manufactured, what the capabilities and functionalities we need to have based off of the requirements, all of these things makes your job easier.
So you're talking about the engineer who's making these initial decisions. Who else in the business might benefit from master data and digital threads?
Supply chain's the biggest beneficiary.
Okay.
Because when you start talking about one of the key things that I've seen at every company I work for is you have 10 part numbers for the same part. Why do you have that? Right? Well, some of it's just old designs that people didn't have the digital thread to be able to find things in, right? You didn't understand that I could very easily go off and find a 1/4-20 screw. You looked in your binder that listed all the part numbers out back in the day. And if you didn't see one, well, okay, we're just going to create a new one. And especially as you look at industry and what has been the trend in recent years, especially in automotive, right? We're all buying companies, selling companies. And when you start to have growth via acquisitions, you really need to have a clear master data strategy to identify what's critical to be able to get rid of all the redundant parts. Because as you start talking about synergies between organizations, especially within your supply chains, that's real tangible savings for companies.
Yeah, it also helps with the whole incident. I got to use the careful words. When you have a breakage in the field, right? You got to go figure out, okay, what's the root cause? Is it the individual part? It's the way the part was used, right? Maybe the wrong fastener was used in a particular location. But yeah, quality wants consistent naming so they can do the investigation. And if they have inconsistent naming, your example of combining companies is an excellent one. Well, then you get lost. You don't know what parts you're talking about as you try to investigate. Were these parts built at factory over there, and it was this lot on a Monday morning? That's where the problems are, right? It was a particular lot that had parts, not the design, but just the way the part was manufactured. So the quality organizations clearly benefit from master data. In fact, they might be the biggest advocate if you have lots of quality problems. Now, hopefully you have no quality problems, and it's just a check mark, right?
Right. And again, it depends on the company. What if the traceability of parts in the field is what's critical, then again, it's understanding the criticality of the data.
Now there's a dangerous topic, but let's go there for a second about traceability of parts. Some people have said that part numbers on a individual part should reflect the product they're in. Now, you think this through, the trouble is that'll create more and more part numbers, right? So the same bolt will have a part number when it's in a sedan versus the same part number when it's in, or a different part number when it's in a truck. So imagine the logistics, the supply chain confusion. Well, it's really the same part. It's just used in two different vehicles. And because the vehicle quality people wanted to track it uniquely, they gave it a unique number. That this becomes insane at some point, right?
Right. And what you're talking about, actually, I would argue, is a carryover from previous generations of design. Because smart part numbers are the way companies used to have to do it, so that they would be able to, without computers, without being able to very easily identify attributes, they would build that all into a part number. So you have a part number that identifies what plant is it in, what color is it, what size is it, what type of a part is it. My last company that I worked for, we had a part series for die castings, a part series for machine parts, a part series for purchased assemblies. And the reason that they had that was a carryover from before we could identify attributes that would then describe the parts, right? So while a unique identifier is needed so that you can have something that tracks your part, that's all that it is. It's just a unique identifier. Everything else about that part really should be considered an attribute that describes it. You don't, in a digital context and in a digital world, you don't need that. So if I was, the guy implementing this type of a concept at one of the new electrical vehicle startups, my part numbering scheme would be start at 0000001, and we go from there.
Yeah,
because the part number should not mean anything.
It's just this number. It's just a number that's unique, right?
It's a unique identifier, nothing else.
Interesting. So I hope there are folks listening. There's a lot more in that debate. But yeah, the smart part numbers is actually, ironically, an indication of dumb PLM systems, if I can go there, because they don't put together the attributes and the numbers that could give you a smart, intelligent, unique name, which is really what you could do.
Right. And I wouldn't say that it's necessarily the fault of the PLM system. It's more an indicator of how old your company is.
The culture of the company,
and the culture of the company to embrace change.
Interesting. All right. So this question about conflict for a moment, naming conflicts. So master data can exist, but as you bring silos together, you mentioned companies being combined. Do you have some insight on how do you get to that data dictionary, that one source of defining what a word means? I mean, you got some advice for the rest of us?
I'll be honest with you. It's something that I'm working on as well. It's not an easy thing to achieve. And I think fundamentally it requires collaboration between several different functions. And where it gets complicated is when you have a global organization. I've been working with a team in Sweden that also has locations in Thailand. And I'm trying to tie it into existing naming conventions that I've put in place for the US and Germany and China and India. And while, words may have similar meanings, as soon as you say the wrong one in that company, and somebody snickers and says, "Oh, well, why did you do that? What does that word actually mean? What is the context? What is the context of that word the way you heard it?" So there's a lot of discussions that need to happen. And it's really just through collaboration where you start to define that master book of names. Now, where I think even gets more complicated is when you start talking about, all right, well, how do I start establishing what all of the redundant duplicate parts are, and how do I manage that from a data context? And I would argue that by establishing your master data strategy will help you do that, right? What are the key couple pieces of information that I need about a part so that I can stack them all on top of each other in some record, so that I can then have a common record that ties them all together, right? And that's where master data management comes in. That's a whole.
So I have this picture in my mind, and partly it's based on my experience, but there's a group of experts from these different places in the world, and so you have the good discussion, you have the collaboration. How do you decide? You just vote? Do people, like every political process, do people just you agree my way on this one and I'll agree your way on the next one? I mean, how do you get to the one definition that you need going forward?
So whenever I work through any type of a discussion like this, and I'm the one leading the organization or leading the process, I go to the leadership team and I say, I need a couple of key empowered decision makers.
Okay.
These are the people that are going to make the decision, period. And
they're going to help roll it out when you when you inform everybody else, right?
But those people, they can't be people that just have the bandwidth to work on this project. They need to be the people that are probably your busiest ones. And
right.
Those are the people that work on PLM implementations. That's the ones you need. Those are the people that you want for new process rollouts. And unfortunately, they're the people that you also need for establishing what your core master naming conventions and all these things need to be. And
so
it can be done relatively efficiently, but it's, you do have to have those decision makers that just drive it down and say, this is it. That's what we're using. Done.
Right. And that, and actually that, if I could add to that, yeah. And the decision makers can enforce that by requiring that that's the terminology we use henceforth. And every senior level manager review, we're not talking about bolts, we're talking about fasteners, yes. Right? If that's the way we've chosen to use the language, right?
Exactly.
So that really is about trust, right? Organizational trust. And then the cool thing about PLM is it can make the data transparent, right? And so a lot of times people just need to see, especially engineers, we just need to see the evidence. Oh, 90% of the people call it fastener. I guess the 10% of us that want to call it bolt, we should just learn a new word and live with fastener, right?
Yep.
And when they realize that fasteners are many, not just bolts, but also screws, even glue, even hemming, right? There's different ways of fastening things. Now, all of a sudden, the word fastener is the action, the why, whereas bolt is the what to achieve the why. And so sometimes you just got to have those basic debates. Are we talking about the why? Or are we talking about the what? Or are we talking about the how? Right?
Yep.
And that can help the debate along.
Yeah,
well,
absolutely.
As always, Adam, it's good to chat with you. I'm glad to see you're actively making things happen in PLM and the Digital Enterprise Society. And with that, I'll send it back to Thom.
Absolutely. Thank you very much. And so, Adam, I like to end all these episodes when I have time to get a piece of career advice out of each of our guests. And in the introduction, and when Craig first started talking to you, Craig brought up a really interesting point. And that was that you have a background in mechanical engineering, and yet you're the IT director. And what stuck with me is I wanted to ask you, if somebody listening to this feels that they're pigeonholed into a discipline, because that's who they are and that's what they do, how does somebody transform into another area within an organization?
Well, I'll be honest with you. I think a lot of people see what they're doing at that point in time and don't necessarily take into consideration all of the experiences that they've had throughout their life and throughout their career. Because really, it's about cross-training, right? You think of an athlete, right? The best athletes try doing lots of different things. They're not just focused on one individual thing. So really, what you can be is a culmination of everything that you've ever done in your life. That's who shapes what you are. So people that say I'm pigeonholed, look a little more broadly about your interests. What are you interested in? What have you done in your past that can support that? And then what extra piece of cross-training can you do that might help you take a step in that direction? And it might be, something that is, very plainly obvious to you, but or it may not be. It may be part of your current career. It may be just going off and volunteering at some strange place. If I want to make a jump into carpentry, maybe go volunteer for Habitat for Humanity. If I want to learn more about, the digital enterprise and how these systems that we've been talking about are connected, come join our team and volunteer for the DES. There's there's opportunities to kind of step out of your immediate pigeonhole, get some experience that then might give you some opportunities to jump. And it also might give you the contacts via some networking, which I know is one of Thom's favorite topics is networking. It might give you some contacts to help you make that jump as well.
Awesome. See, this is why I ask every guest for that little nugget of career advice, because you never know when one of the listeners is going to need to hear exactly that. And I love the advice to volunteer for the Digital Enterprise Society, because I'll tell you what, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. And Craig and I want you to join us here every week for more thoughts, ideas, and information all around product lifecycle management. And Craig and I have a favor to ask you. If you like this podcast, go tell your friends, go tell your coworkers. We want more people to be getting access to all of this learning. And you can check it all out and more that is offered at Digital Enterprise Society by going to digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.